once again. I want to teach you about Kubernetes, the most basic things about Kubernetes, and make it very simple. And actually the goal of this tutorial is to simplify Kubernetes. I have found it being explained or being taught with some very heavy terminologies and maybe in ways that is hard to grab for a person who is new to it, but I want to explain it in the simplest ways possible. You don't need to be an expert in IT. You don't need to have a degree in computer science. You don't need to understand rocket science. You just need your empty brain. Just come with your empty brain, and I'll start without wasting much time. Yes, and I assume your brain is as empty as this page. Yes, when we start about Kubernetes, I assume you don't know anything about Kubernetes. And even without telling you what is Kubernetes, I want to draw something in your brain. So I'll start with drawing a big box here, and then from that box, that's where we will work from. So I want you in your brain, I want you to draw this big, big, let me just make it so that you can fit the size here. I want you to draw this imaginary box and assume this is an enclosed network. I don't want to give you terminologies. I want to give you images, visualizations. This is called demystifying Kubernetes. Very simple, very simple. So okay, you have that imaginary network in your brain that you have drawn here. Then we have some other boxes here. Let me just draw these boxes here. And now I've told you to assume that this is an imaginary network. In this imaginary network, we have some servers. Yep, we have some servers. And as much as it is demystifying, I assume you know what is a server. I want to assume you know what is a server. And basically, this is a node. This is a node, or you can just call it an EC2 instance. And maybe this is EC2 instance have some properties. Maybe it has a RAM of let me just do it better. Don't be lazy. Let's create some resources here. Make it like 20 gig. That is for storage, memory, and then we have maybe RAM. A RAM of like 3 GB RAM. Yep, this could be 20 GB memory. This could be like the disk memory. The goal is to make things simple, not yet to make anything look difficult. So that's a server, and in this server, let me just group these things together. Can I group them together? Can I copy them? No. just do this, copy RAM, this one. Why are you not copying? Now assume you have another server somewhere. Yep, you have another server, and let me just copy these ones because they refuse to copy. And that's another server. Yep. And after that server, now you have another server here. That's what we call a cluster now. Yeah, that's what we call a cluster. Like, we are creating a cluster. A cluster is a collection of servers. Cluster is a collection of servers. Now we have no 4 servers. We have 4 nodes. Yeah, that's basically what Kubernetes entails. It's a cluster. So let's continue adding our servers. We don't want to have so many. We just want to have this cluster of servers. And let's beautify our cluster. Our Kubernetes to look something like, let me show you this one. So that's our cluster. Our cluster have these beautiful nodes. They are plain in white, very beautiful. Yep, that's our Kubernetes. If I can put a very beautiful title here and call it Kubernetes. Yep, Kubernetes. Yep, let me just change this color to some grayish. So it's our cluster, and let me expand it because it's something that I'll add. So Kubernetes is a collection of servers. And why do we have a collection of servers? Why do we need all these servers? Yep, we want these servers because we want to create an application that is very highly available. Yep, so that we don't want to rely on one node, we don't want to rely on one EC2. If this EC2 goes down, yep, if this EC2 goes down, like our application goes down, and we don't want that. Yep, if this EC2 dies, yep, we can't access our application, and we don't want that. Like, assume you are building a software, maybe for the bank transactions, and you want them to be as available as possible. Very resilient application. So that's where now Kubernetes will come to help you. That is the most basic definition of what is Kubernetes. And this is a cluster now. That is the first thing that you need to understand. That is the most basic thing, the most basic introduction about a Kubernetes and cluster. Now let's go to step number 2, or then it's the second thing. Now Kubernetes has something that is called now you see all these servers here. They have, I'll call them their head boy, or their class teacher. Just use the term. Let me now. We have this guy here. It's like a big server, but not that big server. I don't want to assume it's a big server. Actually, it's one of them that has the least work to do. It's an office. Now it's an office. They have a headquarter. this cluster has a headquarter, and this is headquarter where all the decisions about clusters, about the whole cluster, are made. Which application needs to be deployed where? All the decisions are made here. And in this class, in this now, in this let me just give it a better color so that looks like a real staff room or a boardroom. These are decisions are made. Yeah, looks better. Is that a good color? I don't know. Do you think? No, don't look it like that. I think that's okay. That's fair. I settle on green, not this green, but which green? Let me settle on this green, not this green. I need something that will be very much contrasting from the rest of the components. So yeah, keeping things simple, as we said before, we have 4 guys here, and these 4 guys in this office, I'll tell you what they do. We have that guy who is called API server. We have another guy here who is called scheduler, and we have another guy here. Basically, we have 4 guys here in this office. We have 4 guys here, and this office looks so big. You can actually make it smaller, because in actual sense, the office, these APIs are, these are, we call this what, let me just space these ones here so that I can have a title here and call this office what, control plane. This is where all the instructions are managed. This is where all the decisions about which application is run where, what is the status of the cluster, which application is running where, they all happen here. So understand this is a staff room. Yep. And maybe just to give a simple what is the role of each and every guy here. This guy is called the PA server. He accepts, processes requests from the clients. Basically, if I told you this is a network, and in this network there's no traffic that is there's nothing that enters in this network without this guy. Like, this guy is the entry point. Whenever you want to get into the cluster now here, anything that you want to communicate to the cluster, you talk to this guy here. Yeah, you talk to this guy here. He's the entry point to the cluster. Maybe you have a software that you want to deploy into the cluster, you have to talk to this guy. Yeah, he communicates and fulfills the request from the outside. Yeah, keeping this simple, as we said. Okay, from there we have another guy that is called the scheduler. We have this guy who's called the scheduler. This scheduler, he's responsible for assigning pods to nodes. Pods is something that you are going to talk about here. It's something that you're going to hear many times, so get used to that. Yeah, Kubernetes is a game of pods. Yeah, so this guy assigns pods to the nodes. This guy is the one who assigns pods to the nodes. And then we have the control manager. Control manager is a guy who manages the cluster and ensuring that the desired number of pods, yep, are running, and he handles again the pods when they fail, and scaling the deployments, yep, keeping things simple. etcd or etcd, he's actually like see, he has a database, he has a register, yeah. He's the one who gets reports and he stores the status of the cluster. If this node dies, or if this node goes down, or if the node is full, like if this node is not healthy, this guy is the one who registers. If a pod dies, he's the guy who registers. Yeah. So that is the work of the control plane. We have those three managers. Yep. API server, scheduler, controller, and etcd. Keeping this simple. That is the control plane. So control plane basically manages the cluster, and each of them has their own role. Let's now come to something now interesting, some more interesting things. Now we have I've mentioned a pod, and a pod, I want to explain a pod as from the Docker context. Let me assume you know what is Docker. Docker is where, let me just go deeper for the sake of maybe guys who don't know what is Docker. Assume you have an application, yeah. Assume you have an application here. You just drag something here. Just put something here. Assume you have an application that needs Java. Yep. This application needs Java. Let me just separate these ones here because I don't want you to mix things up. You are developing a Java application that has Java 17. Maybe needs maybe let's say we have maybe Node 18 version, some version 18, and yeah, these examples may not make sense, but maybe you have something like another dependency. Call this the dependencies, and maybe something else like yeah, maybe just those two, yeah. But your application, you want it to run anywhere in your what, regardless of the operating system. So we have this guy who loves Windows, we have this guy who is addicted to Linux, and he loves this guy who is mad at Mac OS. Yeah, they want to work with their own machine. They are software developers, yeah. But this guy wants to use Windows. Yeah, he's so good at Windows and he can do magic. This guy knows like Ubuntu, and he's so comfortable working with Ubuntu. And this guy is always he can't use anything else than Mac OS. But they need to work on this software. Yeah. So Docker gives you a what? Docker is a platform. In this platform, you create your what? You define what your software needs, all the needs in your software, and you put them in one place, and that is what is called an image. Yep. Then from that image, you can run containers, keeping things simple. Container is a runtime of a Docker image. Let that sink. A container is a runtime of a Docker image. So an image generates a container. When an image is installed that does not have anything, it is not instantiated. Instantiated means it has not been implemented. So it's called an image, and we store images in Docker Hub, keeping this simple. Container is a runtime. Container is an implementation of the Docker image. That's it now. So when we talk about pods, yeah. So I've explained what is a container. So a container, they are the things that we are going to work with now. Now we want to assume now your application is ready to be deployed into the cluster, and now it's in form of a Docker image, and when it starts running, it will run as a container. So those containers are the ones that we will deploy into the cluster, right? So I want to draw something, and then as I draw, I'll explain. Like we started with an empty cluster, I want to do some things here. I don't want to do that. I want to have this here. Assume now this is your application and it's running. This is a container. Yep, this is a container. But this container, Kubernetes does not manage containers. Kubernetes actually manages, let me show you something else. Not a container. Let me show you just a minute. It manages something that is called, so we have this guy here. So inside the node, now we have something that is called a pod. This green part is called a pod. And a pod is where Kubernetes let me show you, let me just bring this forward. Yes, now Kubernetes places the container inside a pod, and you'll come to appreciate pods because they do an amazing job. Yeah. So a container has been placed inside a pod. So all your worries about a container is now abstracted. Like, you don't need to care about this container as long as it's working. You've done the hard work of developing that software. Maybe it's a Java software, it's saving the database, yeah, and it's doing all the good job that you have instructed it to do. Now you've deployed in a container. You're right. Container has an IP address. Let me show you. A container has an IP address here. And now this is what we call a container here. Just want to make this look very much pretty. So this is a container. As a container, it has an IP address. A pod as well has an IP address, of which now is going to be different from the container. Maybe we give it a 2. Yep. So this is an IP address of the pod. And now this pod, now when this software starts to run, Kubernetes automatically networks it with the pod. Just make this look pretty. So the networking here is done. So you don't need to know on which IP address this your application is running from. Yeah, and you just know that your application is running in a pod. Yep. Let me just bring these ones down. Actually, I enlarge my network because it's going to grow bigger. Our network is growing. We are adding things into the cluster. Yep. So it's just one node. You don't have like so many nodes. It's just one node that you want to make sure that things look pretty, and just want to create some space. Just want to create some space here. I'll draw this one so that we keep things simple. So yep, so this is an pod and its IP address. This is the container now that is running inside that pod, and the networking already is done. I don't have to keep drawing those networking things. Yeah, but now assume that now this is your node here. I don't need to have these maybe descriptions of the resources. Maybe let me do this. Let me just keep things together because you're going to have many. We can group them. Let's just group them together. Yeah, you come on. They're no longer together, so just come and I want to keep things pretty. The prettier they are, the prettier you'll understand them. Yeah, but assume now that is a pod. A pod has a container running inside it. Can I group this one together? Yes. Can I duplicate them? Okay, so that is one pod that is running inside that EC2 instance. And this pod, because we have a container running in a pod, and in most cases you have one container in one pod, but there are exceptions. But in most cases you have one container running in a pod. So for example, you want to scale your application and you want to have many instances, so that you want to duplicate your application so that your application is available in these other servers here. Yep. So you have one instance here of your application running in one node or running in one EC2, but our goal is to have your application run in different servers. Yep. So you can have another instance of your application running in another just a minute. I'm trying to keep things very much pretty. Yes, that's good. Now you can have your application now running in two different servers, two different nodes, such that if your application goes down on this server, it's available on this server. Yep. And again, if your application goes down, basically we are distributing our risks. Yep. If your application again goes down on the two servers, it's again available on this server. Remember, these are duplication. Yep. Like we are having redundancy. We are duplicating this application into different nodes, and this is what we call replication, and we are going to see that what is replication. So we have now our application duplicated in 3 different nodes. For it to be, let me just delete this one and add this beautiful pod here. Yep. So our application is running in 3 different nodes. So our request can, if a customer accesses our application, they can be served from this node, or they can be served from this node, or they can be served from this one, or they can be served from this one. Perfect. Up to there. That is another good part to understand how our application gets distributed. But there's something else that I want us to address: the containers and pods. Containers and pods, they can die anytime. They don't have a big lifetime. For example, if the application crashes, the application that is running here crashes, this pod dies. This pod dies. This pod will die. This pod will die. If the application inside it crashes, that pod will die, and it will not be available anymore. Yep. It will not be available anymore. But Kubernetes will create another pod. Kubernetes will create another pod, but this time things will change. This will be another IP address, like it will be something like 17 something, 176, and you can just maintain the other numbers, and the pod will change as well. The pod will change its IP address. Yeah, but you see now, the communication of these pods, pods needs to communicate to each other. Maybe you have this is your application pod, and maybe you have another pod for what? You have another pod or another container, of course, pod in another container. So this pod is a database pod. Just for example, we give it a beautiful color of let me see, beautiful color of that one. I want to give this part this color, not this one. Okay, colors. Yes. So these are 2 pods, and your application maybe depends on you can develop your application in different pods. Maybe this is your application, this is your core application, this is your database, container, and they can't communicate because one, this one was dead. Yeah, this container died at some point. This container died at some point, and the moment it died, it was Kubernetes generated this a new pod with some new IP addresses. So that's a problem. So to mitigate that problem, Kubernetes introduces something that is called a service. And I want to move things together. I want things to move together. Yes, like that. Yes. You're not complicating anything here. So Kubernetes introduces a service, and a service is the one that exposes the network from a cluster. So a service exposes traffic to and from the cluster. That is the work of a service. Maybe if I can draw it vertically, I think it will look better. Yep. And then maybe delete this line and make it, yep. That's a service. A service will expose or will sit in front of the in front of a pod. The good thing about services, their IP address does not change that much, or not that much. They don't change. Forgive me for saying they don't change that much. They don't change. So if now, for example, we have this service and it will be assigned 192.101.189. This IP address will never change. Like this, the services don't get destroyed. Yeah. Pods and containers, we call them ephemeral. They can die anytime. When the application dies, they die and they get assigned new IP addresses. But a service will always be there. Yeah. A service will always be there. So in the case now where this pod, everything dies inside that pod, you know Kubernetes will do what? Kubernetes will come and create a new pod, and because your service is already there, now service will be able to connect automatically, will hook automatically to the container, to the pod. Yeah. So you only call your services, you don't communicate to the pod. You don't need to know which pod is running where. You just need to know where are your services running from. Yep. Like this service. So this service represents this pod. I would give an example of a lawyer. This is a lawyer, this is a client. And a client does not speak in the court of law. It's always the lawyer who speaks. Yeah. If they have anything to answer, the service will do an internal communication to the client and ask, did you murder someone? And they'll communicate. And now this guy is the one that will tell the cluster, the whole court, like, yeah, my client did not do anything. Yeah, my client is innocent. That's a funny example. So that is the relationship between a node and a service. And I want to explain something else. When we scale an application, we just duplicate nodes. Yeah. we duplicate, no, sorry, we don't duplicate nodes. We duplicate the pods. Yeah, I want to give you some more space here. You guys are taking much space. Yep. So we have this. These are what? These is another pod. I don't know why they are separating each other. I want to move this guy down here. You come on, move together. Not you. Okay. Assume we want to scale our application. Yeah. And we want to create another pod so that requests, for example, when you have too many users in your system and you want to duplicate your what, Kubernetes will automatically maybe scale out. You want to scale your application and you have another node here. You have another pod here, and this pod has been created from this one, and in most cases you'll have two of them managed by one service. Yeah, so you'll have two of them managed by one lawyer. If we go by that one lawyer here. Yep. So this guy is represented as well by the same service. So this service will be representing two pods, and we don't need to know about the details of the pods, how many they are. This service will know which to call. Yeah. And we can actually have something like a load balancer. A load balancer is where now we have I don't know why that is behaving. A load balancer is where now this service maybe you can have like something like yes, something like a load balancer here that will know which pod to direct that request to. Yeah, to direct that request to, so that you don't always send request to one pod. Remember, your application is distributed into different pods. And now talking about replication, I don't think it makes sense to replicate a pod in the same node, because our idea, the whole idea about cluster or Kubernetes is to distribute our risks. So let's say that we want to scale our application and we want to give it another pod. Yep, we have another pod that has been created. Yep, this service here can serve this pod here as well from another pod, from another different node. And that is the beauty about Kubernetes. You don't need to know what is running where, which pod is running where, because these pods can be what? These pods can be assigned to any node. And the control plane here keeps the register of the healthy nodes. How much CPU do you have? How much memory are you remaining with? What is happening within this node? Like, for example, you've come with your application now and you want to deploy it. You tell the API server, hey, please, I have this container that I want to deploy. Yep. So you have come with your container here. You have a new container that you've built from a Docker image. Yep. So I want to duplicate this part, but it's refusing. So you have come with your container from the outside the cluster, and now you come, hey, hello, I want to deploy this container to this container for you. Yep. Then this guy will ask the etcd, what is the status? We have this guy who wants to deploy a container, and what is the status of the cluster? This guy will check from the register. Okay, he wants to deploy a container. Okay, let me have a quick look at the cluster. So in this database, we have some empty nodes that actually don't have any application running. So tell the scheduler, tell the controller, I mean, yeah, because the controller is the one who sets who manages the state of the cluster and ensure the desired number of pods are running, handling the failures, and scaling the deployments. That's the work of a control manager. Yep. Okay, actually the guy who is going to assign this pod, this controller, this container, now this guy will actually schedule the container now. And as we said, now Kubernetes is going to wrap. Yeah, Kubernetes again is going to wrap your container in a pod, and it will be deployed somewhere. You don't define actually, although I believe you can define, but you give Kubernetes that responsibility. Yeah, you trust Kubernetes to deploy your container. So your container now has been wrapped like a very good gift and has been deployed to a node that probably you can define which node, but because Kubernetes has the knowledge of which node is healthy, which node is less busy, and which node does not have a lot of work, yeah, so that you don't put all your pods in one node, yeah. And if this pod again, yeah, was being represented by this service, Kubernetes will network that for you automatically. Yeah. So making things simple again, a container, you don't care about a container how it's running, you only care about a pod. And a pod is represented by a service. Pod and container are ephemeral, they die. Yeah. Services, they expose all they manage traffic between the cluster outside the world and inside the pod. And if a pod dies, Kubernetes will make sure that it is replaced immediately. And that is the work of this guy, the controller. He's the one who makes sure that a pod is replaced immediately. If you define your application, you want to have always a replica set of 4. That is how you want to have 4 instances running at any given time. This controller guy will make sure that your requirements are met. Yep. So yes, and I think now that is what is called Kubernetes. And as you can see, it's not something rocket science. I don't want to go into so many things in depth, but I just wanted to you to understand that Kubernetes is just a cluster that has these guys, the head office, control plane, and have some nodes. Yeah, have these nodes here, and these nodes is where you run your pods. Yeah, and your pod, inside the pod is a container. Inside the pod is a container, and then we have services. Services, they are the ones that expose a pod, and if a pod dies, the controller guy immediately replaces that pod. Yeah, I want to show you maybe a kind of complete image here, so that you can you can have a picture of what is a pod, like the whole cluster. So API server, scheduler, controller, etcd. So a pod is getting represented by a service, and a pod, a service, a pod, a service. But as we said, a pod, one service can actually represent many what? Yes, you are right. A pod, a service can represent two pods. Yep, running in different nodes, and you don't care about the networking. So ladies and gentlemen, that is Kubernetes for you. You don't need to, from here now you can be able to read in depth, go to YouTube, watch tutorials, and but as long as you have these basics, you are able to understand what is a cluster. And yep, in case you have any question, let me know. I'll do another video, maybe how to deploy a simple application in the cluster, and so that you can gain confidence and see your application running. Yeah, thank you guys. Goodbye.